sir.
Okay. So let us begin with tutorial 1. Fine. Samir has joined just now. Sorry. Samir, Rahul, both of you need to turn on your video. Say, if I remove you from my session, you won't be able to attend my session again. Okay? Yes. Fine. So at present, I have all the students who are attending with video except the Rahul Advani. Fine. But those who are attending, for them, there is this tutorial 1. We have 9 such tutorials. Okay. The tutorial 1 says that you need to sketch these signals. Okay. First of all, okay, let me tell you again, because most of you are present. You need to note down each and everything whatever we have been discussing here. Fine. And at the end of the tutorial session, I will ask all of you to submit your work through the Google form, and we will follow this practice in all tutorials. Okay. Fine. Now, as you can see, the first problem is about sketching signal, different signals like step signal, ramp signal, parabolic signal, okay, impulse signal, and we need to sketch all these signals in continuous time and discrete time. Okay. Now in final examination, you may be asked to draw signals like this, not here. But before you draw these signals or you sketch these signals, you need to understand the basics of signals also. Okay. So let us begin with elementary signals. So first of all, let us understand how you can represent a signal. Fine. There is a graphical representation which we will always follow, right? There is a functional representation which also we will always follow, because functional representation means it will be a kind of mathematical equation. It will be a mathematical equation. And most of the signals, as we know, those which are deterministic signals, we represent them using mathematical function. Fine. Arbaz, you are supposed to join at the time. Okay. Not after 15
Okay.
minutes.
Okay.
Okay. So here we have a functional representation. Then we have a tabular representation. Okay. We will see all of them one by one. And we also have a sequence representation. Fine. Now out of this, the graphical represent, sorry, just a minute. The graphical representation is something wrong. Fine. Okay. So the graphical representation is done in both continuous time and discrete time. Okay. Graphical representation is done in continuous time as well as discrete time. Functional representation is also done in continuous time and discrete time. So many times, see, the short forms will be used, fine, in case of CT and DT, fine. So CT, just a minute, this is a case causing a lot of issues. Wait a minute. Okay. Tabular representation is normally done in discrete time. Similarly, sequence representation is done in discrete time. Understood? Okay. Graphical and functional representation are done in continuous time and discrete time both, whereas tabular and sequence representation is normally used in discrete time. Okay. So let us understand one by one. This is called graphical representation. Fine. Where we draw a graph. Fine. For example, consider a signal at -2 instant. This is called instant, and it is represented using n. So at -2, once again, all of you are supposed to draw this along with me. Okay, not this one, but when I start discussing step signals and everything, then you need to draw it. So I will tell you when to draw. Don't worry. So at -2 instant, we have a value -3. Fine. Wait a minute. Maybe I need to bring a stand, or I need to use a book probably. Let me check if I have a book. I will put that book right here so that okay. So now you can see me. So at -2 instant, we have a value -3. At -1 instant, we have a value 1. Sorry, 2. Here is -3. At 0, we have a 0 value. Fine. Similarly, at 1, we have a value 3. At 2, we have value 1. And at 3, we have value 2. Okay. This is called graphical representation because we are drawing a graph. In a functional representation in discrete time, of course, there is no definite mathematical function for the signal which I had drawn here. Okay. So in a functional representation, what we do, we write x of n is equal to -3 for n is equal to -2, 2 for n is equal to -1, 0 for n is equal to 0, 3 for n is equal to 1, 1 for n is equal to 2, and 2 for n is equal to 3. This is called functional representation. Fine. Another example is that x of n is equal to 2 raised to n. This is an exact mathematical function. So sometimes you may have a mathematical function, okay, to represent a signal, and sometimes you may have values like this. These are used in finite signals. That means those signals which are defined only for specific duration. Okay. Whereas the signals which are defined at all instants of n or t, right? And they are almost, you can say, infinite. They go up to infinity. Fine. Then those signals are represented using mathematical functions like this. Similarly, in continuous time, you may have x of t is equal to, you can say, 2 raised to t for t greater than or equal to 0. and it will be 0 for t less than 0. Understood? Arbaz, you need to turn on your video, as I said. All of you need to turn on your
Yes, sir.
video. Arbaz.
Yes, sir.
Yes. Arbaz, Rahul, and Arjun. All of you need to turn on your video.
सर मैंने ना कल सर वैक्सीन लिया था, थोड़ा तबीयत ठीक नहीं है, इसलिए सर लेट के क्लास कर रहा है सर.
हाँ, तो you can leave. Then you can leave, no problem.
सर ऐसा सर अटेंड कर रहे हैं सर, थोड़ा लेट कर.
नहीं,
ऐसे
ऐसा
सो
नहीं
के
चलेगा,
लेट
ऐसा नहीं चलेगा. I will not allow that.
सर वैक्सीन में पता है सर आपको दिक्कत होता है.
I understand.
सर
You are attending.
सर दिक्कत बहुत हो रहा है सर, बैठने में भी दिक्कत बहुत हो रहा है सर.
वो विशाल को भी हुआ है, वो भी सर देखिए कैसे उसका फेस देखिए सर.
सर आप बोलोगे सर, उसलिए कुछ नहीं करो.
कल ही लिया हम लोग कॉलेज में.
सी देखो, आपको अगर अभी फीवर है, ठीक है, तो मैं क्या कह रहा हूँ कि अगर आप बिल्कुल भी अटेंड करने की पोजीशन में नहीं है, so then you can leave. You can go through my video. Okay? Understand? You can go
ओके
through my
सर,
video
लीव
later
कर
on.
दो सर आप.
Well, I don't want to be harsh, but let me tell you कि जब मुझे एक्चुअल में कोरोना हुआ था और मैं आपका लेक्चर ले रहा था, उस वक्त भी मैं बैठ के ही लेक्चर ले रहा था. समझ रहे हैं?
ओके सर. हाँ हाँ सर, आप लीव कर दो सर.
Rahul Advani, this is the last time I'm telling you. Rahul. Rahul Advani, this is the last time. Okay, I will not consider your attendance. It's very simple. If you don't want to turn on your video, I will not consider your attendance. Simple. Similarly, Arjun, you should also turn on your video. Yes. हम यहाँ पे मस्ती करने इकट्ठे नहीं हुए हैं, देखिए, समझ रहे हैं? जिसको पढ़ना है वो क्लास अटेंड करेंगे, जिनको नहीं पढ़ना है वो नहीं करेंगे. So this is the functional representation. Then we have a tabular representation. Fine. In a tabular representation, we define values at different instants. That means we write the values of n in the first row of table, and then we write the values of function in second row of the table. Okay. So as you can see, at n is equal to -2, the value is 3. At n is equal to -1, the value is 2. And n is equal to 0, the value is 0. Okay. Once again, the tabular representation is used only for finite signals. Okay. Finite का मतलब क्या है? देखिए, अगर मैं ऐसा सिग्नल ड्रॉ कर रहा हूं which goes for up to infinity, this is x of t. It is basically an exponential signal. So if I draw a signal which goes up to infinity, so then this signal is not finite. And then I must define the function of this particular signal. Okay? But tabular representation is possible in case of finite signals. Understand? Okay. So I hope tabular representation is clear. And fourth one is the sequence representation. Same function, same signal, but represented in different ways, right? Sequence representation means we write these values. Of course, you need to put a comma in between. So we write values of the function, and at 0 instant, we put an arrow which indicates upwards. This arrow indicates that this is n is equal to 0. As I said, tabular representation and sequence representation both are used for discrete time signals. Understood? So these are different ways to represent a signal. We will use all of them in a different manner. Fine? But the representation should be very clear. Fine? Okay. Now let us go through these elementary signals. First, 4. And that is the question number 1 of your tutorial 1. Fine? This is the question number 1 of your tutorial 1. First is unit step function. Second is unit ramp function. Third is unit parabolic function. And fourth is unit impulse function. Now, as far as I know, you have already studied all 4 functions or signals in control system, right? Or you might have also studied this in circuit and network, right? Yes or no? Yes or no? You
Yes,
can
sir.
unmute yourself.
Yes.
Okay. But
Yes,
here
sir.
we will also include, try to understand, here we will also include the discrete time function. Fine. And that's how it will be different than the previous one. यहाँ पे हम discrete time function भी discuss करेंगे. Understood? अर्जुन, अभी जो मैं डिस्कस कर रहा हूं, अभी जो मैं एक्सप्लेन कर रहा हूं, ये आपको बुक में नोट डाउन करना है. एंड एट द एंड I will ask you, all of you, to submit the same thing through the Google form. Okay? Fine. So, question number 1. Sketch different signals: unit step, unit ramp, unit parabolic, and unit impulse. Fine. So, we will start with continuous time step function. It is defined as u of t is equal to 1 for t greater than or equal to 0, and it is 0 for t less than 0. Fine? And you draw it like this. Fine? So you will draw a line, horizontal line, which is your x-axis, and on x-axis you will always have either t or n. In signals and systems, you will always have t or n on x-axis. Okay? Whereas on y-axis you will have a function which you want to draw. Fine? So I hope all of you are drawing it. At present, no need to draw this or write this. Fine? Abhi shifted function nahi lena hai. I will explain you what do you mean by shifted function. Don't worry. But at present, you are not supposed to draw this. although I will explain it. So the continuous time step function is defined as u of t is equal to 1, 0. Understood? Rahul, do you listen to me? Rahul?
Sir,
हाँ बोलो
hello.
विशाल.
Sir, the shifted unit step function defined as ये sir इसका draw नहीं करना है क्या?
Yes?
Shifted
हम
unit step. Shifted
हाँ
units.
शिफ्टेड अभी ड्रॉ नहीं करना है, मैं वही बोल रहा हूँ.
Okay, sir.
मैं एक्सप्लेन करूंगा ये कब आपको ड्रॉ करना है, जब स्पेसिफिकली मैं ट्यूटोरियल क्वेश्चन नंबर 2 डिस्कस करूंगा. फाइन. So I hope you have done it. Fine. So continuous time step function is defined as u of t is equal to 1, 0 for t greater than or equal to 0 and t less than 0. Now, this discrete time step function, don't draw this, don't draw this. The discrete time step function is defined as u of n is equal to 1 for n greater than or equal to 0 and 0 for n less than 0. Fine. So it is like this. From 0 onwards, now try to understand, at n is equal to 0, the value is 1. Okay? For 1, the value is 1, 2, the value is 1, 3, the value is 1, and it goes up to infinity. So we put these dots to indicate that it goes up to infinity. Whereas for -1, -2, -3, for all of them, we get 0 values. This is the meaning of discrete time unit step function. And look at how it is precisely defined here. U of n is equal to 1 for n greater than or equal to 0, and it is 0 for n less than 0. Clear? Bhavesh, you are not
Yes,
drawing
sir.
it?
Yes. सर कैमरे के साथ थोड़ा कंफर्टेबल नहीं हो रहा है सर. ऐसा नहीं कर सकते कि वहाँ आप कभी बीच में कैमरा चालू करने का बोलो तब हम आपको ड्रॉ किया हुआ दिखा दे, बाकी कैमरा ऑफ है तो थोड़ा कंफर्टेबल नहीं हो रहा है सर.
कि सामने बुक या कुछ रख दो, जैसे कि मैंने रखा है. अभी मैंने बुक रखी है, बुक पे जो है उसको मैंने वर्टिकल रख दिया है.
सर फोन चार्ज हो रहा है तो चार्जर की केबल लंबी नहीं हो रहा है.
देखो अभी आप सब कुछ सब कंस्ट्रेंट मुझे एक्सप्लेन करोगे तो हाउ व्हाट विल आई डू? See, my purpose, I have already clarified it. My purpose is twofold. One is that you are attending, okay, and second that you are doing the task also.
यस सर मैं कर रहा हूँ, लेकिन
हाँ.
वहाँ आप जब दिखाने का बोलोगे तब मैं दिखा दूंगा. अभी वैसे नहीं
Fine.
हो रहा है कंफर्टेबल लिखने में.
नहीं, आपको सबमिट कब करना है? At the end of this session.
यस सर.
Okay. So I hope you are drawing it.
सर पर वो थोड़ा
Same thing
Sir,
applies to you, Samir.
सर मैं कैमरा ऑफ करके ड्रॉ कर लूं, फिर लास्ट में जब सबमिट करने का होगा तो मैं सबमिट कर दूंगा.
No problem.
Okay, sir. Thank you.
So हो गया सबका?
Yes, sir.
Yes, sir.
Okay, fine. Let's get ahead. Then we have a unit ramp function. I think you have already studied unit ramp function. The continuous time unit ramp function r of t is that function which starts at t is equal to 0 and increases linearly with time, and is defined as r of t is equal to t for t greater than or equal to 0, and it is 0 for t less than 0. Okay? And if you integrate the unit step function, okay, then you will obtain the ramp function. It's very simple. It is, let's say you have 0 to infinity, right? And 1. 1 is for unit step function. And then you have a dt. So obviously, the output of 1 into dt will be t. If I don't define the limit, because limit can go up to infinity, fine. If I don't define the limit, then integration 1 dt is equal to t, right? Okay. So r of t is equal to t for t greater than or equal to 0. It is 0 for t less than 0. That means here it is having 0 value. Fine. Whereas here it is having 1 value. Sorry, t. The slope is equal to 1. Because if you compare it with y is equal to mx plus c, here c is 0. So y is equal to mx. Fine. And if you see that y is equal to t, इसके साथ आप compare करिए, where x is equal to t. So if you compare this, then m is equal to 1. Fine. So that's why you can say that the slope is 1. Fine. This is the shifted one, which I will discuss in the second question. This is the unit ramp function. So as you can see, once again, this is the unit ramp function. The discrete time unit ramp sequence, we call it the unit
Sir,
ramp
previous
sequence.
slide एक बार sir बस दिखा दें.
ये वाला.
Yes, sir. Now it's okay, sir.
So the discrete time unit ramp sequence R of n is defined as R of n is equal to n for n greater than or equal to 0 and 0 for n less than 0. Fine. And you draw it like this. On x-axis have n, on y-axis you have R of n. Okay. And then it is like this. This is 1, 2, 3, 4, and 5. So on y-axis also there will be 1, 2, 3, 4, and so on. You can see that. No need to draw these dashes, okay? But you can see that you are getting values at discrete interval of time. Who is this 9 number? Okay, it's Bhavesh. Fine. Are you done?
Yes, sir.
Okay,
Yes,
let's
sir.
move ahead. Then we have a unit parabolic function. Okay, unit parabolic function. In the unit parabolic function, it is defined as P of t is equal to t square by 2 for t greater than or equal to 0, and it is 0 for t less than 0. That means it is not defined for t less than 0. It is defined only for t greater than or equal to 0. Okay. So mathematically, you write it like this, and graphically, you draw it in this manner. Fine. So unit parabolic function is obtained by integrating unit ramp function. What do you mean by that? So let us say you have a integration of r of t dt, right? Integration of r of t means r of t is defined as t dt. Understood? R of t is equal to t. So you have integration of t dt, which means it is t square by 2. Simple. And that's why P of t is equal to t square by 2. So that means P of t is simply obtained by integrating R of t with variable t. Now see, some people think of this as an exponential signal. This is not an exponential signal, it's a parabola. Understood? It's a parabola. Fine. What is the function of parabola? Y is equal to x square. In this case, y is p of t. So I would write p of t, and x square, so that is t square. And of course, we have t square by 2. So we divide it by 2, right? So y is equal to x square is the generalized function of the parabola, which you have studied in probably schools, right? In the board examination. So that's why this function is called parabolic function. Done with this?
Yes, sir.
Okay. Amit Kumar, Samir, are you drawing this?
Yes, sir. Yes, sir.
Okay, okay, fine. Okay. Should I move ahead?
Yes, sir.
Okay. Once again, I will talk about this unit shifted version later. Fine. This is the discrete time version. Don't write this one. Don't write lower one. Discrete time version of the unit parabolic function. So the discrete time unit parabolic sequence P of n is defined as P of n is equal to n square by 2 n greater than or equal to 0. And it is 0 for n less than 0. Don't write this. सी जब आप 2 घंटे साथ में लिखेंगे तो एडवांटेज ये रहेगा कि एट द एंड व्हेन यू आर सपोज टू सबमिट योर ट्यूटोरियल वो ऑटोमेटिकली आप टाइम टू टाइम सबमिट हो ही जाएगा, आपका खत्म हो जाएगा. अदरवाइज क्या होगा, आप 2 घंटे यहाँ पे मुझे सुनेंगे एंड देन यू विल सॉल्व इट वंस अगेन ऑन योर ओन. ओके, और फिर क्या करेंगे, उसके बाद सबमिट करवाएंगे एट द एंड, राइट. Instead, we want to utilize these 2 hours to solve examples. You also have some kind of understanding. Fine. Of course, आप कुछ प्रॉब्लम्स जो है मैं आपको दूंगा सॉल्व करने के लिए, तो सबके सब मैं सॉल्व नहीं करवाऊंगा. That is certain, right? It is not possible due to time constraint. Fine. हाँ, I will share वीडियोस जिसमें आपको सबके सब सॉल्यूशन मिल जाएंगे. डोंट वरी. ठीक है. So this is unit parabolic function sequence in discrete time. So look at that. See, for example, this is 0. See, this is 0 at 0. Now n square by 2, it's the generic function. For n less than 0, it is 0. And for n greater than 0, it is n square by 2. For 1, it is 1 by 2. So this is 1 by 2. Right? So it's 0.5. For 2, it is 2 square by 2. That means it is 4 by 2. So I get 2 here. For 3, it is 3 square by 2. Okay? So it's 9 by 2. For 4, it is 4 square by 2. So it is 16 by 2 means 8. And that way it will keep on rising. Understood? So this is your parabola. If you join these dots, you realize that it's a parabola. Shifted नहीं लिखना है अभी, बाद में लिखेंगे. I hope you have done it. Vivek Kumar is still drawing. Rohit is still drawing. Amit Kumar is still drawing. Okay. Okay, done. And then we have this unit impulse function. Okay. So you are only supposed to sketch it. So don't write this theories. Anyway, it is available in the book. Fine. Okay. So the continuous time unit impulse function, also called Dirac delta function. It plays an important role in signal analysis, and it is defined as integration minus infinity to infinity delta of t dt is equal to 1, and delta of t is equal to 0 for t other than 0. Okay. So what does it mean? What does it mean? It simply means that if I draw something on time axis t, then there is this Dirac delta function delta of t. Okay. Now try to understand, if the width of this impulse is delta t, then the height will be, sorry, delta, not delta t, sorry. Just a minute. So I need to erase the thing. Fine. If the width is delta, let us say, then the height will be 1 upon delta. Understand? It means that if the width is very, very small, then the height of the impulse is very, very large. Okay? It is very, very high. If delta approaches infinity, sorry, 0, then 1 upon delta may approach infinity. But it is not true. Okay? And this is something what you see in the, you can say, unit impulse or the lightning strike. Fine. Though the actual nature of lightning strike will be a little bit different, but that's what you see. Smaller is the time, higher is the impact. Fine. But if you try to find out the area under the curve, so what do you mean by area under the curve? That is height multiplied by width. So if you look at the area under the curve, then 1 upon delta into delta will always give you 1. That's why this is defined like this, minus integration. Okay, now area is always calculated using integration, right? आप में से कौन कौन ऐसा है जिसको पता नहीं है ये? है कोई ऐसा जिसको पता नहीं है? If you want to calculate the area under the curve, then you need to integrate the equation, right? From the lower limit to the upper limit. In this case, the lower limit is minus infinite, upper limit is infinite. Okay. So if you integrate it, finally you will get 1. Understood? So though mathematically we know this, but it is very difficult to realize or understand the unit impulse function. But remember, unit impulse function is the link between your continuous time system or continuous time signal and the discrete time signal. Understood? Fine. Now, if I draw this same thing in discrete time, then probably it will become much easier for you to understand. In discrete time, the unit impulse function is defined as delta of t is equal to 1 for t, okay. In discrete time, delta of 1 is equal to 1 for n is equal to 0 and 0 for n is not equal to 0. Simple. Don't do this. So it's simple and straightforward. At 0, it has value of 1 and for all other instances, it is 0. If you look at the discrete time version and the continuous time version of unit impulse function, then both of them will look same, right? Both of them will look same, right? But unit impulse function is very, very important signal, okay? And we are going to use it extensively in signals and systems, okay? तो आगे जाके यूनिट नंबर 2, यूनिट नंबर 3 के लिए नहीं है, पर यूनिट नंबर 2 और यूनिट नंबर 4, if you want to understand these 2 units properly, then you must understand this impulse function, okay? और बहुत ही क्लियर होना चाहिए आपके दिमाग में. फाइन. हो गया? Okay. Now, let's go to question number 2. Okay, now question number 2 में अगर आप देखेंगे तो 3, 4, 5 जो है ये ऑलरेडी मैंने ड्रॉ करके दिया हुआ है पीपीटी में. So when I share this PPT, probably you will understand what I mean. Okay, let's talk about question number sub question number 1 for question number 2 of this tutorial, and that is x of n is equal to 2 raised to n for n greater than or equal to 0 and 0 for n less than 0. Let's go for it. So sketch this function. Fine. Now this is a discrete time function. Okay. So on x-axis, we will have n. Sorry. On x-axis, we will have n. So this is n. Arey yaar. Fine. And here we will start from 0. At 0, okay. So we will start at 0. Now what is 2 raised to 0? So 2 raised to 0 is equal to 1. So I will draw 1 here. Remember, it's a discrete time signal. Then 2 raised to 1 is equal to 2. Don't write this 2 raised to 0 and 2 raised to 1 here. Okay? You are not supposed to write it. You are only supposed to draw it. So 2 raised to 1, this is 2 raised to 0. 2 raised to 1 is 2. So this is 1. This is 2. 2 raised to 2 is equal to 4. So at 2 instant, you will get 4. And at 3, it is 2 raised to 3 is equal to 8. So you will get some value here, 8. And after that, you don't need to draw it because it is an infinite function. So you can put some dots here. Similarly, at -1, you will get 0. -2, you will get 0. -3, you will get 0. The reason is that it is 0 for n less than 0. समझ में आ गया?
Yes, sir.
तो ये हो गया आपका नंबर 1. Have you drawn it? Okay. So I will go to the next. ये पता नहीं ये कहां से आ गया है. ओके. अभी सेकंड नंबर जो है दैट इज x of n is equal to -3, 2, 0, 3, 1, 2. Okay. So how will you draw it? First of all, draw x-axis carefully. पता नहीं है, कुछ टूल में कुछ इश्यू है. Okay. Now at 0, 1, 2 and 3. Right? अभी इसको नीचे लिखेंगे तो it will cause some problems. So ये कौन है? ठीक है. तो 0 पे क्या है? This arrow indicates n is equal to 0. That means it is like this. Here we have n and here we have x of n. So you can write this in a tabular form as -3, sorry, at n is equal to -2, the value is -3. At n is equal to -1, the value is 2. At n is equal to 0, the value is 0. At n is equal to 1, the value is 3. At n is equal to 2, the value is 1. And at n is equal to 3, the value is 2. So I will start with 0 here and I will draw 0. After that, what is this? At 1, I am getting 3. So it is 3 here. At 2, it should be 1. So I am drawing 1 here. And at 3, it should be 2. So I am drawing 2. At -1, sorry, at -1, it should be 2. So I am drawing 2 here again. And at -2, so you can write on x-axis here and here 1, 2, 3. And at -2, it is -3. This is on x-axis you have n, on y-axis you have x of n. So this is the sketch of signal. Have you understood this?
Yes, sir. Very well.
No, sir.
Who is saying no?
Sir, please explain this one and how to write n -2, -1, 0, 1, 2, 3.
See, you need to look at the value at a particular instant. Right? Now, how will you define those instant? You take arrow. That arrow will be considered as 0th instant, right? All instants on the right hand side, they belong to positive. And obviously you can't skip that value. So you will get 0, 1, 2, 3. Similarly, on the left hand side, you will get -1, -2, -3, and so on. Okay. So first of all, define the 0th instant and write the value of that instant. So it is 0 in this case. Fine. Now this 3 belongs to n is equal to 1. So basically, see, it is like this. X of n is equal to, yes, sir, there is a pad issue. X of n is like this. It is equal to here x of -2, x of -1, x of 0, x of 1, x of 2, and x of 3. It is like this. Okay. And how will you find out x of 0? So arrow indicates at x of 0. Understood? Understood the point? All of you?
Yes. Yes, sir.
Yes, sir.
Right? अभी क्लियर हो गया विशाल कुमार, अर्जुन कुमार?
Yes, sir.
Sir, clear है sir, clear.
Okay. This is the simplest form of representation where you have all the values and then you write, you draw those values. Okay. And we have successfully done this in schools also. But here it is a bit sophisticated. It looks a bit sophisticated. Okay. Fine. Now u of t minus a, r of t minus a, and p of t minus a. So let me explain all of them one by one. Okay. First is u of t minus a. So that's why I denied all of you to draw it. The u of t minus a is the shifted unit step function. The shifted unit step function means that if it is t minus a, then it is shifted by a. Okay. So t minus a means it is 1 for t greater than or equal to a, and it is 0 for t less than a. Understood?
Yes,
This is
sir.
how you define the shifted unit step function. Clear?
Yes, sir.
Okay. And then you draw it. So how will you draw it? That depends on your mathematical function. So you need to draw 1 for t greater than or equal to a. So a is here. It is some value a. So for the value greater than or equal to a, it is 1. And for t less than a, it is 0. This is called unit step function. Understood? So you draw it. That is the equation number 3. Sorry, question number 3. सिर्फ ड्रॉ करना है आपको। डन, ठीक है। नाउ द नेक्स्ट वन, दैट इज delayed unit ramp function. Delayed unit ramp function. See, here also it is very simple that the delayed unit ramp function is defined for t greater than or equal to a. Okay, so its value is t minus a for t greater than or equal to a, and it is 0 for t less than a. Understood? मतलब क्या है कि ये जो लाइन है उसका इक्वेशन क्या होगा, t माइनस a. If I draw it here, I call it t, and if I draw it here, I call it t minus a. Okay. Now, how did I get this equation? How did I get this equation? So it is very simple. Let us derive that equation. See, it is y2 minus y1 upon x2 minus x1 is equal to m. This is the equation. Fine. And we had drawn it like this. This was a, and this was x of t, and I call it t minus a, right? Now what happens, let us say we have a random function here. Sorry, I call this function, I call this instant t and value y. Okay, I call it t and y. Whereas here it is a, x value is a, and y value is 0. समझ में आया? At some
Sir,
instant
repeat, sir.
हाँ, at some instant t, जो मुझे मालूम नहीं है अभी, the value that I have assumed is y. Okay, I call it x2 y2, and here this is the known one. At I call it x1 y1. At a we are getting y is equal to 0. दिख रहा है? Okay, so if I substitute the same, then I will get y minus y1 is 0. Okay, if I compare this with everything, then what happens? X1 is equal to a, y1 is equal to 0, x2 is equal to t, and y2 is equal to y. That's what I have assumed. So y minus 0 upon x2 is t minus x1 is a, and that is equal to m, which is 1, because in case of ramp function the slope is 1. So then I will get y is equal to t minus a. Y is nothing but x of t, so I can say that it is t minus a. समझ में आया?
Yes, sir.
So there is nothing extraordinary about this, but sometimes we may wonder that if, see, if I show this, just a minute. As I said, you might have a question that ramp signal which starts at 0, I call it t, and ramp signal which starts at a, I am writing this as t minus a. Why? So this was the explanation. Fine. Now, next is shifted version of unit parabolic sequence, P of n minus k. So P of n minus k is defined as P of is equal to n minus k whole square by 2 for n greater than or equal to k. And it is 0 for n less than k. This is the shifted version of unit parabolic sequence. Fine. And you have to draw it like this. Understood? Let me draw it for you. Fine. So let me draw it for you. So fifth one is P of n minus k, which is equal to n minus k whole square by 2 for n greater than or equal to k, and it is 0 for n less than k. Fine. And then we will draw it here. Now let's say that this is 0. For 1 also it is 0. For 2 also it is 0. And we go up to k. Now try to put n is equal to k here, and you will get, if n is equal to k, what will you get? You will get, for n is equal to k, the n minus k whole square by 2 is equal to 0, because n and k are same. So then you will get 0 here. If n is equal to k plus 1, then k plus 1 minus k whole square by 2 is equal to 1 by 2, because k and k will cancel out. So at k plus 1, you will get 1 by 2. Similarly, for k is n is equal to k plus 2, you will get 2. K plus 3, you will get 9 by 2. And then it continues up to infinity. So this is how you draw P of n minus k. Understood? Okay. Is it clear? Okay. Now the third question. This is the third question. X of t is equal to ae raised to alpha t. Fine. Now how to draw this? It's an exponential signal, by the way. It's an exponential signal. Okay. So how do I draw exponential signal? Let me show you. Okay. So the question is sketch x of t equal to ae raised to alpha t, where a and alpha, they are real. So assuming that a and alpha both are real. Fine. So when alpha is less than 0, your signal will look like this. This is for alpha less than 0. See, when t is equal to 0, it will be a e raised to 0. E raised to 0 is 1, so you will get a. And that's why you get a here. Okay, this is 1, this is 2, this is 3. So alpha is less than 0. Less than 0 means, for example, let us say that alpha is equal to 2. So then this will become a e raised to minus 2t. Understood? A e raised to minus 2t. If I have to draw a e raised to minus 2t, for t greater than 0, obviously it will decay in this manner. But one thing which we have not observed so far, because we are always starting at t is equal to 0. The one thing which we have not observed is that the same curve will continue in the negative direction and it will go up to infinity. Understood? So there are two directions. One is t less than 0 and another is t greater than 0. So for t greater than 0, if alpha is less than 0, then the exponential will decay, okay, and it will approach 0. Whereas for t less than 0, the exponential will grow and it will approach infinity. Similarly, if alpha is greater than 0, let us say that it is alpha is equal to 2. So you have a e raised to 2t. Now here in t, if you substitute the value greater than 0, then this will grow and it will approach infinity. Not this, but this will be a. And as you go towards negative, so then it will approach 0. Now, anybody has a question related to this? Though we have studied this in schools, okay, but some of you might be having a question. And see, this is a very basic, okay. All these signals will they will not be directly asked in examination, but they will be very, very useful in understanding concepts in our subject. So any question? Arjun, are you done with drawing? Arjun, आपका ड्राइंग हो चुका है? अर्जुन, आई एम आस्किंग यू.
हेलो.
हाँ बोलो.
यस सर, हो चुका.
ओके फाइन. विशाल एंड
Yes,
विवेक
sir.
कुमार,
Yes, sir.
आपका हो चुका है?
Yes, sir. Yes, sir.
And who is this 11 number? Eleven number? Why have you turned off your video? Eleven is, I think, Deepu Kumar, right? Deepu Kumar, turn on your video. Okay, so see, these are two conditions. These are two conditions of exponential signal. Either the exponential signal will decay with time. As the time progresses, it will decay. We call it decaying exponential. It may grow. We call it growing exponential. I think you have already studied this in a control system, right? If your response decays over the period, you call it stable system. Okay. If the transfer function of the system gives you a growing exponential, right? So then you call it unstable, right? We will talk about the stable and unstable system also later on, not now. Okay. But this exponentials help you understand the nature of this system, whether it is stable, whether it is unstable, or what. Okay, now one question. Just a minute. Something is wrong. Okay. One question. What will happen if alpha is equal to 0? Tell me. Can somebody tell me what will happen if alpha is equal to 0? Yes?
Infinite.
What?
It become a
It becomes
A.
A. Very good. Very good. And how will you draw it?
Sir, straight line on A.
Great. That's what I wanted to hear from you. Okay. So, see, so here I will also draw the y-axis. Fine. And x of t equal to a e raised to alpha t. Now, because let me explain others. T is equal to 0. Sorry, alpha is equal to 0. So, x of t is equal to a e raised to 0 into t. So that is a e raised to 0. And e raised to 0 is 1. So you get a. So you constantly get a value. So that means if this is a, let us say, So then you will get a horizontal line passing through A. This is the condition of alpha is equal to 0. Okay, but remember this is also an exponential.
Sir, we can draw it.
Sure, you can draw it. Mhm. Done?
Yes, sir.
Okay. Now the next function. The next function is, it's a question number 4. Wait a minute. And it is called signum function. It is called signum function, signum of t. The signum function is equal to 1 if t is greater than or equal to 0. And it is 0, it is minus 1 if t is less than 0. Okay. So basically, if you have, let us say, time t on x-axis, then signum function will have sine okay. So it will have a sine -1 value for t less than 0. And it has 1 value for t greater than 0 or greater than or equal to 0. So basically, this, what does this function show? This function shows only sine of time. Understood? It only shows sine with respect to time. Okay. If time is greater than is equal to 0, you will get 1. If time is less than 0, it is -1. Understood?
Yes, sir.
It is, see, it's kind of non-linearity, and it is very, very useful in many cases. Okay, so whenever you encounter it, you will get to know that how important it is. Fine. Okay, after that, there is one more function which is very, very useful in communication. Okay, and that is called sin C function. The sin C function is defined as sin t divided by t for t ranging from minus infinity to infinity. Understood? Sin C function, is defined as sine of t divided by t for value of t ranging from minus infinity to plus infinity. And if you have to draw this, you can draw it like this. This value is 1, is called sin C function, right? Here it will have capital T minus capital T, 2t minus 2t, and so on. X-axis is t. So this is called sin C function. As you can see, as the time progresses, the value decays. Here also, as the time progresses, the value decays. It's a kind of hyperbola. So it decays with value 1 upon t. This is also 1 upon t. Why? Because it is 1 sin t upon t. So that's why. Okay. But there is one important question. If I write sin t upon t, that means at 0, at t is equal to 0, we should get sin c of t is equal to sin 0 upon 0 for t is equal to 0. Then why are we getting 1 here? Tell me. If you have studied mathematics earlier during your school, and you must have gone through this sin 0 upon 0, and yet you are getting 1 value. How is that possible?
Because sin 0 ની વેલ્યુ 0 થાય એટલે 0 by 0 એટલે 1.
0 by 0 is undefined value. It cannot be defined, dear. 0 by 0, 1 by 0, anything divided by 0 is undefined value, right? Infinite by infinite is also not defined. So tell me, it's very interesting one. Okay, if you can recall, it's good. Not, then it's fine. But if you can answer this, I will be more than happy. See, whenever you encounter this kind of scenario where the value is completely not defined, then you should apply, yes? Okay, and what is that intermediate form, Bhavesh?
Sir, zero by zero where यहाँ पे वो है कोई वैल्यू फाइंड नहीं होती, हमारा इंटरमीडिएट फॉर्म फिर उसको वो उस फंक्शन में वापस करते हैं ऐसा कुछ।
You are not clearly audible, Bhavesh. Okay. Okay, let me show you. We apply L'Hospital's rule, right? To such indefinite, not root, its rule. Okay, where in such case, where sine c of t is equal to sine t divided by t. So what you have to do, you have to perform d by dt of numerator and d by dt of the denominator, and then you put t is equal to 0. This is called L'Hospital's rule or L'Hospital's rule. Now when you differentiate sine t, you will get cos t divided by, when you differentiate t, you will get 1, and then t is equal to 0. So that is cos 0, and you will get 1 there. Understood?
Yes, sir.
And that's why here you are getting 1. There is something wrong with the program. And that's why you are getting 1 there. I will try to switch to a different program from the next week. So don't worry. We are not going to face this problem. Okay. Now I'm sharing a link with all of you so that whatever you have done, you can submit. I will share it in our WhatsApp group. So I've already shared that link. In WhatsApp group.
Sir,
યસ
આપણે આજ અત્યારે જે કર્યું એ તો આપણે મીન્સ કે રફ વર્ક હોય તો આના પ્રમાણે તો માર્ક નહીં હોય ને, કે મેન તો કેનવાસ પ્રમાણે જ હશે ને સબમિશન.
yes, marks will be assigned according to the canvas, but I insist that you do the fair work here if time permits. Okay, see, it's all about time constraint. So if you do the fair work and proper work right in the tutorial session, okay, you will have to do minimum work in after the session. So that will reduce your work. Okay, see, the overall purpose is to utilize these 2 hours effectively, right? So that you don't do the same thing again and again. It's that simple. So you submit it today just as a proof that you have done the work, and then whenever you complete the tutorial, at that time you can submit the entire tutorial in Canvas. Clear? मतलब કે
Yes, sir.
અત્યારે જે તમે ક્લાસ વર્ક કરો છો ને એ જ સબમિટ કરાવવાનું છે. ફાઇન. અને જ્યારે કમ્પ્લીટ ટ્યુટોરિયલ પૂરું થાય ત્યારે તમારે આખું ટ્યુટોરિયલ કેનવાસમાં સબમિટ કરાવવાનું છે.
ઓકે સર.
ઓકે, ધેટ્સ ઇટ.